In this illustration, the situation is about a bead sliding on a string. Here in figure shown, the bead of mass m is free to slide on the string with some friction. And it is saying if rod of mass m, which is greater than the mass of bead, and system is released from rest, and at t equal to 0, bead is located in front of one end of the rod as shown. We are required to find the friction force between a string and bead if after t seconds bead reaches the opposite end of the rod. Here we can redraw the situation as well as the free body diagrams of the rod and that of the bead. Here we can see on rod the string tension will act in upward direction and downward will be its weight mg. On a string, as it is experiencing mg in downward direction, it will experience friction in upward direction because it is sliding down due to weight, and the string will get a developed tension downward, and the value of tension is equals to the friction on bead because the friction on a string is in downward direction, which will give rise to the tension in string on the right hand side. And as string is light throughout, the string tension can be taken seen. So if rod is falling with an acceleration a1 and bead is falling with an acceleration a2. So here we can write equation of motion for rod and bead are. Here we can write these equations. For bead we can write it is mg minus f is equals to ma2, and for rod we can write this capital mg minus, obviously the tension is equals to friction, that is equals to me1. So from here we get the value of a2 is equals to g minus f by m, and a1 here we are getting is g minus f by capital M. Now if we calculate the acceleration of rod with respect to bead, if we consider bead to be at rest, rod is falling with respect to bead, and acceleration of rod with respect to bead will be this a1 minus a2, so it can be given as f1 by small m minus 1 by capital M. This is what we are getting for acceleration of rod with respect to bead. And as rod is of length L, here we can say if in t seconds rod travels L distance, we use L is equals to half acceleration of rod with respect to bead into t square. Here this distance is with respect to bead only. Here we can write this distance is with respect to bead. So here the value of L we can write as half acceleration of rod with respect to bead is this. So this is f by 2, 1 by m minus 1 by capital M multiplied by t square. This implies the value of friction force we are getting is 2mml divided by m minus m multiplied by t square. This is the final result of this problem.